Welcome everybody. I am Sriram Dandekar. I welcome all of you on behalf of Navakokon Education Society's DBJ College, Chiplun. We are studying 11th Standard Commerce Section 2 Mathematics. We have finished first lesson and you are going to solve the miscellaneous exercise as I told you in the previous lecture. Solve that miscellaneous exercise in a separate notebook which is to be submitted when we will meet in the college. Now we are going to start with second lesson, measures of dispersion. In this lesson we are going to study meaning and definition of dispersion, the absolute and relative measures of dispersion which are range, interquartile range, variance and standard deviation, and coefficient of variation. Let us recall concept of the constant and variable. Something which never changes under our consideration is called as constant. For example, if I say area of a circle, the formula A is pi r square. Here pi is constant and A and R are variables. That means they change their values according to the situation. For different values of R, different areas are there. In this case, R is variable, pi is constant. Or if I say fx is equal to 3x square minus 7ax plus 5. Now here x is variable, 3 minus 7, 5 are constants, and a is also considered as constant. This a may be a variable, but globally for locally it is a constant, because up to the evaluation of function, say if I want f of 1, then it is 3 into 1 square minus 7a into 1 plus 5, that is 5 plus 3, 8 minus 7a. This is a constant thing. For different values of a, this can be different, but for the variation of x, a is constant. So the concept of constant and variable is now clear to all of you. Second concept, the concept of an average. In schooling days you have studied averages. You have studied mean, mode and median. Mean, mode and median you have already studied. In the first lesson we have studied median. It is also termed as second quartile. Mode is the observation which occurs maximum number of times, and mean means the ॲव्हरेज. मराठीमध्ये त्याला आपण सरासरी म्हणतो. किंवा तुम्ही काढलेले आता जे पर्सेंटेज आहेत, 10वीत तुम्हाला मिळालेले पर्सेंटेजेस आहेत, ते पर्सेंटेजेससुद्धा मीनमध्येच येतात. मीन डिनोट केला जातो एक्स बारने. इट इज समेशन एक्स आय डिवायडेड बाय एन. दिस इज द फॉर्म्युला फॉर रॉ मीन, फॉर रॉ डेटा. And if frequency distribution is given, grouped or ungrouped, for both the cases the mean can be calculated. X bar is equal to summation fi into xi upon n. This formula you have studied in your 10th standard. We need this formula in our further study. Then we have studied quartiles in the previous lesson, Q1, Q2 and Q3. Q2 is the median, Q1 it is the observation below which 25% observations lie and above which 75% observations lie. Similarly, Q3 and Q2. Now Q1, the formula is n plus 1 upon fourth observation. Q2 is 2 into n plus 1 upon fourth observation, and Q3 is 3 into n plus 1 upon fourth observation. For the frequency distribution, the formulae for quartiles you have studied, Qi is equal to L plus H by F into bracket I into n by 4 minus Cf, where L is lower limit of ith quartile class, H is class width, F is the frequency of ith quartile class, and Cf is the cumulative frequency to the previous class of the quartile class. Now all these things we have already studied. This is just for revision. An average does not tell the full story. It is hardly fully representative of a mass unless we know the manner in which individual atoms scatter around it. A further description of the series is necessary if we are to gauge how representative the average is. This is given by George Simpson and Fritz Kafka. The first line tells the thing. Average does not tell the full story. We will take some example in the due course and you will understand this. Why? For example, the data of 3 batsmen. See here, 3 batsmen X, Y and Z. 3 batsmen are given. Their runs scored in 5 respective matches are given. Look here, for all the 3 batsmen, the total is 250. Since the total is 250 in 5 matches, the average, that is mean, for each batsman is the same. But here the first batsman, lowest score is 6, highest score is 104. Once it is in 90s and 3 times he is below 50. The second batsman, 40, 60, 55, 50, 45, 3 times he has scored 50 and 2 times near 50. And the last batsman, the lowest score is 5, highest score is 112. Once it is in 90s, just like X. Now, since all have average 50, if somebody is not out, then also this average makes a difference. All the above series same size n equal to 5, the same mean, but they are different in composition. Thus, to decide who is more consistent, a measure of central tendency, that means average, are not sufficient. We need some other measure, and such measure is that of dispersion. This is the use of dispersion. Why we need dispersion? To understand the composition of the given data, we need dispersion. So let us define that dispersion. The definition of dispersion is given by Spiegel. The degree to which numerical data tend to spread about an average value is called variation or dispersion of the data. I repeat, the degree to which numerical data tend to spread about an average value is called the variation or dispersion of the data. Consider two series, series A 0.5, 1, 1.5, 3, 4, 8, and series B 2, 2.2, 2.6, 3.4, 3.8. Let us plot these on a number line. Consider this a number line. Now for this number line, the minimum value is 0, so I am taking 0 here. Then 1, 2, 3, 4, 5, somewhere 6, 7 and 8 onwards. Now here for the first series, I will plot the first series with blue color. 0.5 is this first value, second value 1, third value 1.5, next value is 3, next value is 4, and next value is 8 somewhere over here behind me. So look here, spread. This spread is from 0.5 to 8. Now look at the second series. Let us plot it with different color. Let us plot it with green color. 2, 2.2, 2.2 somewhere here. Then 2.6, 3.4, 3.8. Both these series have 5 numbers each, but this B series, its spread is smaller than the spread of the series A. The spread of series A is greater than the spread of series B, and therefore I can say that series A is more scattered than series B. And this thing we are going to study in this dispersion lesson. The commonly used measures of dispersion are range, semi-interquartile range or quartile deviation, variance and standard deviation. Firstly, range. Range is the simplest measure of the dispersion. It is defined as the difference between the largest value and smallest value in the data. Thus, range is equal to largest value minus smallest value, that is L minus S. The very simple example, suppose the following data gives weights of 10 students in a certain school. Find range of the data. See all the weights given here. Out of these weights, the largest weight I can observe is 73, and the least weight I can observe here is 36. The largest is 73, smallest is 36. Largest minus smallest, that gives you the range. 73 minus 36 equal to 37 is the range. Now if the data is given in frequency distribution form, then for this frequency distribution form, the lowest value, the lower limit of the lowest class and upper limit of the highest class. Upper limit of the highest class is 150, lowest limit of the lower class is 30. 150 minus 30, 120 is the range for this data. Many times range is not a suitable measure of dispersion. For example, if you consider scores of a batsman, then making a triple hundred is a very, very rare phenomena in cricket. You know that. A person scoring triple hundred and his minimum score may be 0, then his range is 0 to 300. this is not something given by his characteristic, and therefore some different measure of dispersion is required. Somewhat this purpose is given by quartile deviation or semi-interquartile range. We observe the largest and smallest values in the data to find the range. It is if the data contains extreme values or outliers, then the range is an incorrect measure of variation. In such cases, we use measure of dispersion based on quartiles to get rid of the effect of the extreme values. This measure is called as quartile deviation or semi-interquartile range. It is defined as follows: quartile deviation, it is equal to Q3 minus Q1 upon 2. Q3 minus Q1 is interquartile range. Interquartile range divided by 2 is the quartile deviation. The semi-interquartile range Q3 minus Q1 upon 2 or quartile deviation abbreviated as QD. Find semi-interquartile range for the following data. Marks of 11 students in mathematics are given to us. Firstly, arrange the data in ascending order. After arrangement, n is equal to 11, so q1 is equal to n plus 1 upon fourth observation, third observation is 58. Similarly, q3 will be ninth observation, it is 75. Ninth observation is not 75, it is 79. So ninth observation is 79. Semi-interquartile range or quartile deviation QD, quartile deviation is Q3 minus Q1 upon 2, Q3 79, Q1 58, 79 minus 58 upon 2, it is 10.5. Next solved example is find the appropriate measure of dispersion for the following data. Now the data given is less than 50, 59, 50 to 70, 102 and so on, and above 150 there are 52 values. Now less than 50 means what is the smallest, we don't know. Above 150, that means how long it reached, we don't know, and therefore we cannot use a range in this case. Since the classes given are with open-end intervals, the only measure of dispersion that we can compute is the semi-interquartile range. So for that semi-interquartile range, we have to find out quartiles. So make a table. Less than cumulative frequency is done over here. N is equal to 1000. So n by 4 is 250. First quartile class is 70 to 90. 70 to 90 because 250 lies in this class. And third quartile, it is 750, it lies in 110 to 130 class. So using our previous lesson technique formula, Q1 is equal to L plus H by F into N by 4 minus CF. 70 plus 20 upon 125 into 250 minus 161 gives us the answer 84.24. Similarly, the third quartile is computed. The third quartile is Q3 equal to L plus H by F into 3N by 4 minus CF. After calculation, it works out to be 123.4. A good number, 123.4. So quartile deviation is Q3 minus Q1 upon 2, that is 123.4 minus 84.24 divided by 2. It is equal to 39.16 divided by 2 equal to 19.58. Let us discuss exercise 2.1. The first question is find range of the following data. the data is given to us. Range means the largest value minus smallest value. In this case, the largest value is 729 967. 967 is largest value and the smallest value is 250. So 967 minus 250, whatever may be the difference, is your answer range. The second question, for the following data gives number of typing mistakes done by Radha during a week. Find the range of the data. The table is given: Monday 15 mistakes, Tuesday 20 mistakes, and so on. Now we have to find out range of this data. The largest value is 21 and least value is 10. 21 minus 10 is 11 is the range of this data. Third question, find range of the following data. Now here the frequency distribution table is given. The first class is 62 to 64, then 64 to 66, and so on. The last class is 70 to 72. So range in this case is the lower limit of first class or lowest class and upper limit of the highest class, difference between them. 72 minus 62 is range for this problem. Question number 4. Find quartile deviation for the following data. The data is given to us. Now out of this 4 and 5th, both are similar problems. I will solve only 4th one. 5th one is also some raw data is given. From that raw data we have to find out the quartile deviation. Let us copy this problem to our board. Find quartile deviation for the following data. Firstly, arranging the data in ascending order. Smallest is 3, it occurs 2 times, 3 3, then 5 5 5 5, afterwards 8, then 9, then 11, 15 16, 15 16, 17, 19, 1 2 3 4 5 6 7 8 9 10 11, 1 2 3 4 5 6 7 8 9 10 11. So here value of n is equal to 11. Q1 is the n plus 1 upon 4th observation, that is 11 plus 1 upon 4th, that is third observation, and third observation in the sequence is 5. So Q1 is 5. Q3 is 3 into n plus 1 upon 4th observation, that is 3 into 3, that is 9th observation. 9th observation is 1 2 3 4 5 6 7 8 9. The 9th observation is 16, and therefore quartile deviation is formula Q3 minus Q1 upon 2. it is 16 minus 5 upon 2, 11 by 2, that is 5.5. This problem ends here. Let us solve this fifth problem also, since it needs somewhat calculation. Given below are the prices of shares of a company for last 10 days. Find quartile deviation. 172, 164, 188, 214, 190, 237, 200, 195, 208 and 230. Let us arrange the data in ascending order. The data is arranged in ascending order of their values. Now n is equal to 10. So q1 is equal to n plus 1 upon 4th observation equal to 11 by 4th observation equal to 2 3 by 4. 2 3 by 4, that is second observation plus 3 by 4 times third observation minus second observation equal to second observation is 172 plus 3 by 4 times third observation is 188 minus 172. This is equal to 172 plus 3 by 4 times 16. 4 1s are 4 4s are 12. So 172 plus 12, it is 184. Q1. Now we want Q3. Q3 is equal to 3 times n plus 1 by 4th observation. It is 3 into 11 by 4, that is 33 by 4th observation, that is 8 1 by 4th observation, that is 8th observation, plus 1 by 4 times 9th minus 8th observation. 8th observation 1 2 3 4 5 6 7 8, 214 plus 1 by 4 times 230 minus 214, it is 214 plus 4, this is 16, 16 by 4 is 4. So 218 is Q3. Now we want quartile deviation. The quartile deviation is Q3 minus Q1 upon 2 equal to 218 minus 184 divided by 2 equal to 34 upon 2 equal to 17. Let us solve sixth problem. Calculate the quartile deviation for following data. X values are given, frequencies are given. Let us make less than type of cumulative frequency here only to save the time. 6, 6 plus 5, 11, 11 plus 3, 14, 14 plus 2, 16 plus 4, 20, 20 plus 7, 27, and lastly 30. So n is equal to 30. This summation Fi is equal to 30. It is termed as n. Q1 is equal to n plus 1 upon 4th observation, equal to 31 by 4th observation, equal to 7th observation plus 3 by 4 times 8th minus 7th observation. 7th observation is 25 and 8th observation is also 25. So 25 plus 3 by 4 times 25 minus 25, it is 25. Q3 is equal to 3 times n plus 1 by 4th observation, equal to 3 times 31 by 4th observation, equal to 93 by 4, 23 1 by 4th, equal to 23rd observation plus 1 by 4 times 24th minus 23rd observation. 23rd observation and 24th observation both are 29. So Q3 is 29, and therefore quartile deviation is Q3 minus Q1 upon 2, 29 minus 25 upon 2, that is 4 by 2 equal to 2. Seventh problem. Following data gives the age distribution of 250 employees of a firm. Calculate the quartile deviation of the distribution. Now in this problem, firstly we have to make a table. Class 20 to 25, 25 to 30, 30 to 35, 35 to 40, 40 to 45, and 45 to 50. Frequencies 30, 40, 60, 50, 46 and 14. Cumulative frequencies 30, 30 plus 40 is 70, 70 plus 60 130, 130 plus 150, sorry 130 plus 50 180, 180 plus 46 226, 226 plus 40, 14 is 240. Make table clearly. Now n is equal to 240. N by 4 is equal to 240 upon 4 equal to 60, and 3n by 4 is equal to 3 into 240 upon 4 equal to 180. In this case 60 lies in this, so this is Q1 class and 180 here. This is Q3 class. For Q1 L, the lower limit is 25, F frequency is 40, CF cumulative frequency to previous class is 30, H the class width is 5. So Q1 is equal to L plus H by F into N by 4 minus CF. Lower limit is 25, H class width 5, F 40, N by 4 60, cumulative frequency 30. So this is 25, 5 8 ja plus 30 upon 8, that is 25 plus 3.75, it is 28.75. For Q3 L, the lower limit of Q3 class 35, F frequency of Q3 class 50, CF the cumulative frequency of previous class 130, and therefore Q3 is equal to L plus H by F times 3N by 4 minus CF, that is equal to 35 plus 5 upon 50, 3N by 4 is 180 minus CF is 130. 180 minus 130, 50 50 cancel, 35 plus 5, it is 40. So Q3 is 40. Now we want quartile deviation. So QD is equal to Q3 minus Q1 upon 2, equal to 40 minus 28.75 upon 2, equal to 28 plus 12 gives me 40. So it is 11.25 divided by 2, 5.625 is the quartile deviation in this case. Thank you for today. In the next lecture we will see the next part of dispersion. Bye for today.